Alright, so we're going to have a look at question 17. So this is question 17, and this is from the 2020 HSC Advanced Maths exam. This is a nice little question. It is an indefinite integral question. It's worth 2 marks. It's a relatively short question. It looks a little bit messy. This is an integral you have to do not through integration process, but through identification of known integrals. So you have to recognize, oh, this looks like a particular type of integral that I recognize. There is some memory in doing this. So indefinite integral of x divided by 4 plus x squared dx. Now actually the key to doing this integral is to recognize that the numerator is of the same order as the derivative of the denominator. So if we look at the denominator here, we have 4 plus x squared. If we differentiate this with respect to x, d dx of this is 2x. 2x is linear, right? The x is to the power of 1. The numerator here, the x is linear. It's to the power of 1. When you have an integral where the numerator is a scalar multiple of the derivative of the denominator, that's a natural logarithm. So on the HSC formula sheet, this comes directly from the HSC formula sheet, we're told f prime of x divided by f of x, when you've got the derivative in the numerator and the function in the denominator, this integral with respect to x is equal to the natural log of the absolute value of f of x plus a constant. And so in this case, it's not actually, the numerator is not a perfect derivative of the denominator. There's a 2 times multiple here, but that's fine. It's a scalar multiple. So we can add that in when we're doing our integration. This is what we're going to be using here. So we know this is going to be the natural logarithm of the denominator. So this means the integral of x over 4 plus x squared dx is going to be equal to the natural logarithm of the absolute value of 4 plus x squared plus a constant. Now we have a scalar multiple missing here. There's several ways you can work out what the scalar multiple is. One way is to think about differentiating this function. If you differentiated logarithm, you would have the derivative of the thing inside the logarithm in the numerator and the thing inside the logarithm on the denominator. So you'd have 2x on 4 plus x squared. In our integral, we don't have 2x, we just have x. And that means we need to be cancelling that 2x, so we need to be multiplying this expression by 1/2. So 1/2 times the natural log of the absolute value of 4 plus x squared plus a constant is the indefinite integral in this case. Now, this question is really fast. It only takes a minute or two, especially if you recognize this as a logarithm. If you don't really have much time, you just finish the question here. Right? This is worth 2 marks. You get 1 for the working, you get 1 for the answer. If you have a little bit more time, you can check this by differentiating the logarithm. So you can do a check. Checking is highly advantageous wherever possible. This is a habit that it's good to get into for university level work as well. When you submit university assessments or papers, the lecturers or professors, depending on what your classes are, really don't want you to just sort of give them answers and say, oh yeah, I think this is the answer. You're really at a level where they want you to submit something and for you to be able to say, this is the answer, and I have confirmed that this is the answer, right? So you can start doing this. In this case, it's actually not very hard. So if we differentiate this, d dx of 1/2 times the natural log of 4 plus x squared plus a constant, the constant goes away. The derivative of the natural log is the derivative of the inside, which is 2x, over the inside, which is 4 plus x squared, and this is all multiplied by a half. The half and the 2 cancel, and this gives us x over 4 plus x squared. Now note, this is what we started with in our original expression, and this confirms for us that this answer is in fact correct. You don't need to do this, but if you have the time, it is a good thing to do, because if you happen to have made a mistake, if you misidentified this question, you thought it was a trigonometric function somehow, or for the extension 1 students, they might think it's an inverse tangent, an arctan, an arcsine, whatever. If you actually try doing it really quickly, you'll be able to work out, oh no, I've made a mistake here, and then you can correct your own answer during the exam. This is very, very beneficial. In terms of the marking, you get 1 mark for an antiderivative with the log function or some equivalent merit. So something like identifying this as a log and attempting to calculate it. And then you get the 2nd mark for having the correct solution, which is 1/2 times the natural log of the absolute value of 4 plus x squared, all plus a constant.